Hello everyone, welcome to my class. In previous lecture, we have already learned how to get information about a file system. Today, I'm going to talk about getting file information. This picture shows the relationship between a disk drive and file systems. A disk drive can have several partitions. Each partition has a file system. A file system consists of 4 different blocks: boot block, super block, inode table, and data blocks. Once again, boot block, super block, inode table, and data blocks. As you can see, data blocks contain numerous files. What is the information of a file? A file has many attributes and contents. Attribute: file type, file ownership, file access permissions, timestamps, number of links to the file, size of the file, number of blocks, and contents. How can I get information of a file? The answer is very simple. Just by using stat, fstat, lstat system calls. These system calls return the information about file you want. Wow, thank you, stat system call, thank you, fstat system call, thank you, lstat system calls. Thank you very much. We just call these system calls to get the information about the file you want. Okay, let's see the stat system call. How many arguments are there? 2. Point path name and point stat verb. Path name means file name. Stat verb means stat buffer. What does the path name point to? Character data type. What does the stat verb point to? Stat structure data type. Okay, let's see the fstat system call. How many arguments are there? 2. ft and point stat verb. ft means file descriptor. Stat verb means stat buffer. What does the fd point to? Integer data type. What does the stat verb point to? Stat structure data type. Okay, let's see the lstat system call. How many arguments are there? 2. Point path name and point stat buffer. lstat system call is similar to stat system call. What does the path name point to? Character data type. What does the stat verb point to? Stat structure data type. These system calls return a stat structure in the buffer pointed to by stat verb. Therefore, you have to know what is stat structure. This is stat structure. You can see the stat structure in detail from this URL. http://man7.org Linux man pages man2 stat 2 HTML, like this. This is manual pages. Probably you have to refer to the man pages many times in order to make a program using Linux system calls. which variable does the stat structure have? Let's see the variables. st underbar dev, st underbar inode, mode and link, uid, gid, rdev, size, block size, blocks, so many variables. Next, let's see the data types of the variables. dev underbar t, inode underbar t, mode t, and link t, uid t, gid t, dev t, of t, block size t, block count t. These data types end with underbar t. Underbar t means these data types are system data types, not basic data type. We have already learned about system data types on Unix and Linux in previous lecture. System data type are for compatibility. Okay? To get device ID and inode number, you have to use stdev and stino fields. stdev field identifies the device on which the file resides. st underbar ino field contains the inode number of the file. Number means identifications. The combination of stdev and stino uniquely identifies a file across all file systems. stdev field has devt data type. devt data type records the major and minor IDs of a device. The major and minor ID of a devt value can be extracted using two macros, major and minor. To get file ownership, we have to use stuid and stgid fields. stuid and stgid fields identify the owner and group to which the file belongs. To get file link count, we have to use stnlink field. stnlink field is the number of hard links to the file. To get file type, we have to stmod field. stmod field is a bit mask identifying the file type and specifying the file permissions. The file type can be extracted from this field by ending with the constant s underbar ifmt. The result value can then be compared with a range of constants to determine the file type. If statburp.stmod ampersand s underbar ifmt constant equal s underbar ifreg, then printf regular file. To get file permission, we have to use st underbar mode field, specifically the bottom 12-bit of the stmod field. It defines the permissions for the file. The 9 least significant of the permission bits are the read, write, and execute permissions for each of the categories, owner, group, and others. To To get file size, we have to use STSize field. For regular files, the STSize field is total size of the file. For a symbolic link, the STSize field contains the length of the path name pointed to by the link. For a shared memory object, STSize field contains the size of the object. To get the file blocks allocated, we have to use STBlocks field. It indicated total number of blocks allocated to the file in 512-byte block unit. Modern Unix and Linux system files use a larger logical block size. The value in stat blocks is always a multiple of 2, 4, or 8, depending on whether the ext2 logical block size is 1024, 2048, or 4096 bytes. STBLK size field is optimal block size for I/O. To get file timestamps, we have to use STATIMES, STMTIME, and STCTIME fields. They contain the times of the last file access, last file modification, and last status change, respectively. They have time T system data type. Time T is the standard Unix time format of seconds since the epoch. Since kernel 2548, the stat structure supports nanosecond resolution for the 3 file timestamp fields. Okay, until now we have learned about getting file information, specifically file attribute. In other words, file metadata. Good job. Thank you. See you next time.